Sorry? You okay with talking closer? Yeah, it's fine. Just... Should be okay. All right. I think this is fine. Oh, it's there. Yeah. Okay. Hi, everyone. Welcome to the talk. Thank you so much for spending your evening with us. Oh, okay. I think this is okay now. Oh, never mind. It's not okay. I think this is fine. Okay. Okay, let me restart. Hi, everyone. Good evening. Thank you so much for spending your evening with us at Rakuten Asia. Welcome. My name is Hannah. I'm going to be talking about LangChain tonight, particularly about building your first AI-based applications, just exploring more about the LangChain framework. But before we start, let me introduce myself first. My name is Hannah. I'm currently an associate software engineer at Rakuten Asia. I'm part of the global ads team. I graduated around December 2023, so I've worked for about 1 year and 3 months from Yale US College. It's the one that's closing down this year, FYI. My past experiences before I joined Rakuten, I was a part of the software house company, a German software house company as an intern, which is an AI developer intern. And this is actually where I first learned about LangChain, and I used it during my internship, which is pretty fun. Yeah, so before we talk about LangChain, can I get a raise of hands if you've ever tried building an AI-based applications? Yes, Thomas. Anyone else? Oh, of course, Daniel. Fun fact: Daniel and I did a hackathon at Rakuten, in which we developed like AI-based applications, which is a UI cards generator. It was so fun. Yeah. So for those who raised their hands, can you share about your experience building this AI-based application, and particularly what tools did you use? Anyone wants to share? Yes. Okay. Is it? Sorry. Continue. Right. Oh, sounds amazing. Okay. Anyone else wants to share? Okay. Oh, sorry. What's your name? That's okay. Suresh? Sorry. GP. Okay, I'm so sorry. So yeah, as GP has shared, I guess one way that we can start building our AI-based application is just calling to the API of one of the models. So in this case, I give an example of OpenAI API, which is just a completion API. So certainly you can do this, and you can build your AI-based application using this. But of course, if you're just starting out with AI-based application, you want to be able to switch models quite seamlessly. And also, if let's say you want to build a chatbot, for instance, you want to be able to save the previous chats that you've already fed to your model more seamlessly, whereas with using this API directly, a direct API call, you might need to control it yourself. So that's where the LangChain framework comes in handy. So LangChain is essentially an open source framework that simplifies a lot of workflows when you want to build an AI-based applications. So that will hopefully be more clear as we go along this presentation. Can I ask, how many of you have heard about LangChain? Okay, that's quite a lot of people. Amazing. So yeah, this is gonna be the outline for my presentation. It's gonna be the what and the why, and then I'm gonna talk about the core concepts and demo, including models, prompts, chains, memory, agents, and then I'm gonna talk about the drawbacks and alternatives, and then we can go to Q&A if we have time. Okay, so start with the what and the why. So as I've mentioned, LangChain is an open source framework for building applications that are powered by large language models, and it enables us to do integration of LLMs with external data sources, tools, and workflows. So yeah, in short terms, it's just open source framework to build your AI application. And why do we choose LangChain in the first place? The keyword here is to simplify a lot of complex workflows that are involving like AI or LLMs. And it enables us to do dynamic interactions, chaining, memory, and agent-based decision making. Yeah, this will hopefully be more clear as we go along. And there are lots of companies that are using LangChain. So Rakuten is actually one of the companies that are using LangChain. The team that I'm working at currently, we're not using LangChain because we're not building AI-based applications. But yeah, there are also other companies such as Google, BCG, so it is widely used. So yeah, I think now we can deep dive into the core concepts and demo. So the first one is models. And of course, models is really the foundation of LangChain applications, because without it, we can't build anything. And of course, the famous one is GPT, that's from OpenAI, Gemini from Google Cloud, from Anthropic, Llama from Meta, and the most recent one, which is DeepSeek, that created a buzz in the developers world. That is very amazing. So yeah, that's one thing that's great about LangChain is we can switch amongst models very seamlessly. So let's just do a demo to show how it looks like. Oh, sorry. Let me find where it is. Okay. So of course, you have to first run the OpenAI API key. And then for models, in here, there are two types of model that we can use. There's the completion model and there's chat completion model. The completion model is more generic machine learning task that's more suitable for that. Whereas chat completion model is more chat specifics. In LangChain, the completion model is using some deprecated endpoints and older models. So in this case, we're gonna use chat OpenAI, which is the chat completion model instead. So yeah, to initialize it is very easy. Just run chat OpenAI. The model you can specify here. In this case, we're using 3.5 turbo because it's one of the cheapest. And then you can set the temperature to, in my case, I set it to 0.7. If you're not familiar with what the temperature is, it's basically a parameter that influences the LLM's output. Less than 1 meaning it's more deterministic and more repetitive, but more than 1 means it's more creative and random, and by default it's 1, which is a good balance. Yeah, so there are other chat models out there as we have talked about. Well, let me just go here. So yeah, with LangChain, there's Chat Google Generative AI. They also have some libraries directly for Microsoft, Anthropic, and etc. So that's one of the main reasons why people use LangChain for this easiness in changing between models. Okay. And the next core concept is prompts. We've heard a lot about prompt engineering. What is it? It's basically learning about how to talk to AI. So prompt is just sending an instruction to the model, and then it will output like the text that's generated by the model, and it can be static or dynamically generated. And let's go to some demo again. Sorry, I don't know why it's not here. So for prompts, there's static prompt like this one, very easy. Just say, hey, translate the following English text to French. Hello, how are you? And then this is the model that we previously has initialized in here. And you just do invoke with the static prompt. And then when you run this, it will just say, bonjour, comment ça va? Which is what we expected. So this is very simple, same as if you're using your ChatGPT. And there's also dynamic prompt here, in which you can use this prompt template from LangChain. basically what this prompt template does is it allows us to do dynamic prompting to put a placeholder here. So instead of translate the following English text to, say in this case, Indonesian, hello, how are you? We can put a placeholder, and then in the input variables, we can define what that variable is to be replaced. So in this case, the input text I define as good morning, have a great day, and then I format my dynamic prompt template, and then I invoke my LLM, and then we'll say, selamat pagi, semoga hari ini menyenangkan. Yeah, so that's on prompting. And there are lots of people who are saying, oh, I've read online that prompt template is essentially similar to F-string. There is not really a need for this, which I guess we can discuss more later. Yeah, so that's for, let me need to go back first. And the next core concepts is chains. So chains is essentially a sequence of calls or operations. And the calls can be to LLMs, can be to external tools, or it can be to data pre-processing step. The graph that I showed here is a simple sequential chain. So basically, you have an input, and then you put it through a chain, and then the output of the first chain will be the next input of the second chain, and then you run it to the second chain, and then you have your output. So I guess to visualize this better, one example for this is, say you want to translate a document that is originally in French, and then you want to translate that to English, and then you want to summarize that document into like a one-liner, for instance. So let's try that. So in the first chain, you have a translate chain, and then the output of that translate chain will become the input of the summarize chain. So the demo for that, is first, of course, you need to import the necessary library for chains. And then for the translation chain, it's the same for the prompt. You can use prompt template, or you can also, this one, prompt template is necessary because you want to have control on the input variables and output variables. And then you can create this translation chain. We're using LLM chain, pass in the model, pass in the prompt, and then pass in the output key. So this output key English text is basically the variable name in which we're going to store the result of our first chain, this one. So translate the following text to English. The result of that will be stored here in the output key. So let's run that. And then the second one will be the summarization chain. Similarly, we'll define the summarization prompt template, and then we'll create the summarization chain, passing LLM, passing the prompt, and then the output key for that will be the summary. And this will be the juicy part, which is creating the simple sequential chain from summarizing and then translation. So now you can just use the sequential chain from LangChain. And then in the chains input here, you can give an array of the chain that you want to sequentialize. And then here, the input variables will be text, because that's the first input that you're giving, which is text. And then the output variables will be two, right? There will be English text and summary. And then this English text will become the input variables of the next one. I think this is a very important part. Okay, so let's run that. Okay. And then we have this input text. They're all in French. I don't understand French. I'm sure some of you might understand French. So now I want to translate this and summarize it. I can just invoke passing the input text into my sequential chain. Let's run that. And so now entering new sequential chain. Okay, so now we have the translated text in here. And then we have the summary, which is AI is the intelligence, so this is what LangChain is actually great for. It's actually really great for chaining. Keep going back to the wrong slides. It's actually really great for chaining, basically to tell the models that, hey, these are the specific steps that I want to take. Yeah. And there are more complex chains aside from the simple sequential chains. There's also, it's called another sequential chain, but I guess there's like some things that are running in parallel, quote unquote. So for instance, in chain tree here, you can pass in the first input to both chain 1 and chain 3, and then the results of chain 2 and chain 3, you can use it as an input for chain 4. There's also router chain. To be very honest, I don't really understand completely, like in much detail, so I'm not going to go into that, but just letting you know that there is like a router chain out there. So I guess continuing from our example in translation chain and summary chain, putting these together, let's say we have the third chain, which is asking the LLM, like, hey, what language is our user input, like the text that we're inputting. And then maybe in chain 4, we can have a follow-up question chain. Maybe we can ask them, hey, can you maybe generate more text based on the summary and based on the language that the text was originally from. So we can do that. We can do a demo on that. So this is the third chain, which is the language chain. Again, like another prompt template, what language is the following review? You see here in the input variables, we use text, which is the same as the first chain here. And then again, run the chain, output key is language. And then for the last chain, which is a follow-up question chain, input variables will be coming from chain, sorry, let me just go back here. From chain 2 and then from chain 3. Chain 2 is summary, chain 3 is language, and therefore input variables will be summary and language. And let's say we want to write a follow-up response to the following summary in the specified language, and then you run this chain. Okay, so now we run the sequential chain again. The same as before, you run an array of chains. You run this input text, and then we'll see the results. So this is the translated text, and then this is the summary, and then this is the language, which is the original language is in French, and then this is the follow-up message from the summary and in the language that we want it to be, which is French. Yes, so that is an example of chain name in LangChain. Okay, are we good so far? Okay, yes. The next one will be memory. So with memory, when we are, let's say, using a chatbot, if the chatbot doesn't remember our previous conversations or they don't have memory, let's say we tell them, hey, my name is Hannah, and then we ask them, do you know my name? They wouldn't know because they're states and they don't keep track, they don't have memory, they don't keep track of what we send them before. So that's why like memory in this case is important, especially for use cases like chatbot. You want to make sure that you maintain the previous conversations. In this case, if let's say I ask them, do you know my name? Then they will be able to respond based on what we gave them in the beginning. So yeah, basically, it enables the system to retain context across interactions. An example is remembering conversation history. And I think one of the most straightforward memory in LangChain is conversation buffer memory. What it does is it memorizes all the previous text until we hit the maximum token limit. And with this, the raw input is passed. So let me show an example for this for it to be more clear. So we have this, the libraries being passed. And then in this case, we want to initialize memory, conversation buffer memory. And then we want to create a conversation chain or a chain. In this case, we're using conversation chain because we know that we want to create something more conversational, whereas LLM chain is usually more suited for like stateless single step tasks. But you can use both either way. Let me run this conversation chain. And then let's say first interaction, I will say, hey, my name is Hannah. Second, I will say I live in Singapore. Third, I will say, what is my name and where do I live? I run this. After I said, hi, my name is Hannah, this is what the response is. Hello, Hannah. It's nice to meet you. How can I assist you today? And then I say, I live in Singapore. then the AI will give this very lengthy description about Singapore. And then I will say, what is my name and where do I live? And, and they're able to retain that information. Your name is Hannah and you live in Singapore. And if we run the memory buffer, this is what's happening, what's being stored in the memory. So what's happening was with conversation buffer memory, as we ask more questions, they just append like the previous two texts that are coming from AI and also that's coming from us humans. Yeah, so that's the conversation buffer memory. But of course, there are limitations to this. And the biggest limitation is that once, because we keep sending the previous chat history, it is possible for us to hit the token limit. And for instance, for GPT 3.5 Turbo, the limit is around 4,027 tokens. So that's not very good if, let's say, we want to have a very lengthy, long conversations. So an alternative to that is conversation summary memory. What it does is it memorizes the summary of previous texts instead of appending everything that we have set to the AI or what AI has set to us. So it's just a summary of the previous texts. I think I will not go deep into the demo for this one, but what this does is, let me just show you. With the conversation summary memory, we are passing on the LLM as well, the LLM model to the memory, because we're also summarizing the previous chats using LLM, using the model, whereas previously in conversation buffer memory, you're not passing the LLM down because you're just appending the previous texts. So with this one, I've run this. When I said, hi, my name is Hannah, the AI, what it does is it summarizes. So it says, Hannah introduces herself to the AI. The AI responds warmly and offers assistance to Hannah. Then I say, I live in Singapore, and they also summarize it again. So conversation summary memory is great if you have very lengthy, long conversations. They're not really good when you have very short conversations. Because if you see here, if you have very low number of interactions, actually conversation summary memory token per call is higher. And that is because they're actually adding more words if there's not a lot of text in the beginning. So let me show you in this one, right? When I said, hi, my name is Hannah, they actually add more words. Hannah introduces herself to an AI, la da 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 da, even though I just say, my name is Hannah. So because they add more words, they add more tokens. And so when we have a short conversation, actually the tokens per call is higher. But then over time, the longer the conversation is, the tokens per call will be reduced. Yeah, so that's for conversation summary memory. And there's also conversation buffer window memory, which means that we'll only memorize only a number of previous texts. So let me show you this one. So this one, we define K to be 2. That means I will only remember, the AI will only remember the last 2 conversations. So in this case, I said, my name is Hannah, I live in Singapore, I love to do canoeing. So that's 3. And then if I ask them, what is my name? They don't remember. I'm sorry. I do not have access to personal information such as your name, because we set the window to only be K equals to 2, which is the past 2 conversations we had. And that doesn't include my name is Hannah. Yeah, so that's for the window, the buffer window memory. And the last one is conversation summary buffer memory. This is actually a combination between conversation buffer memory and summary memory. It memorizes summary of previous interactions, but also maintaining the maximum token limit of the recent interaction, which can be great because the bad thing about conversation buffer window memory is you lose a lot of context as the conversations become larger. And let's say the K is not that large, which can be very tricky. But with conversation summary buffer memory, you want to make sure that previous conversations context are still maintained with that summary while also allowing the recent interactions to still be stored. So actually, it looks kind of like this. This is not unexpected that conversation buffer window memory has like, I guess, the lowest tokens per call. And that is because we're only keeping the last 6 conversations, which is why the tokens is not that much. And yeah, so with conversation buffer window memory, the lower K is, the better the number of tokens. We're not keeping a lot. With conversation summary buffer memory, as you see here, if the max token limit is also lower, the tokens per call is also better because, again, we're keeping less words in, or tokens in, not words, sorry. Yeah, so that's it on memory. Now we're gonna move into agents. We've heard a lot of things about agents recently. A lot of companies now are moving towards wanting to build their own AI agents. So what is agents? Agents is essentially an autonomous systems that use LLMs to decide actions and interact with tools or APIs. So let's say I have this AI agent that can fetch a data to the database for me, that can make a call to external API for me, or do other toolings that I require them to do. And I guess an example for that is a chatbot that retrieves real-time data. So I guess this is why AI agent is really great, because it is able to do a lot of things that we want it to do. And I guess one example that I can show following our examples on translation and summarization is that, let's say we have an AI agent, and then we have 3 tools. First one is translation tool, summarization tool, and calculator tool. I know the calculator is a bit out of nowhere, but adding them there just so that it makes more sense, at least to me, it really helps a lot. So yeah, I think we can show a bit of a demo on this. Let me run this part. Sorry, this. Okay. So of course we want to export like all the necessary libraries, and then we want to define our tools as functions. So the first one is the summarize text function and the translate text function, and we want to run the calculator function, and then we want to put them into the tools, create structured tools using this function, and we want to, in this case, create 3 tools. We run them. And then we want to define the agent prompt, and then we want to create the agent, and also the agent executor. And then this is what happens is in here, we say we have the prompt template, summarize this text. We want to tell AI, hey, please, to the agent, hey, please summarize this text. We run this. Okay. And as you can see here, it invokes the correct tool, which is the summarize tool that we have defined here. Because we have 3 tools, summarize tool, translate tool, and calculator tool. And when we ask them to, hey, summarize this text, the AI agent is able to pick up, oh, we have to use the summarize tool. Similarly, when we ask them to, say, translate this text into Indonesian, when we ask them, again, they're able to pick up here invoking translate, and they're able to translate it to Indonesian. And then when we ask them to like, hey, please calculate this, they're also able to pick up the correct tool, which is calculator. Yeah, and then the result of the calculation will be correct. So yeah, that's why agent is really great, because you're able to do a lot of things and define a lot of your tool with it to do the things that you want it to do. And I guess this is like one question that I had as I was learning about LangChain and preparing for this presentation. I was a little confused between the difference of chain and agents. And I learned that with chain, obviously, as we have talked about this, it's more about the steps. So if you already know what is the procedure that you want your models to look like, chain is great for that. Whereas agents is more about what kind of tools you want your AI agent to have, and if they're not really a procedure. So let's say I want my agent to be able to translate, to be able to fetch data, then you can do that. But it's not like chain where the steps is kind of defined in the sequential chain example that we have shown. Yeah. And so actually for agents, LangGraph is better for that. If you want to manage like multi-agents, for instance, LangChain is mostly ideal if you want to do chaining, clear sequence of steps, and modular design. But for agents and multi-agents, I think LangGraph will be better for it. And my colleague Daniel will have his presentation on LangGraph after this. So really excited for that. Yeah. And of course, there are some drawbacks and alternatives with LangChain. Personally, I've never really deployed LangChain into production, but I read in some open forum like OpenAI community or other forums out there that the main drawback of LangChain is that it has a very high level of abstraction, which can make it very hard for them to control certain things. So they have a lack of control because with LangChain, as we've seen, it has a lot of magics and voodoos. We don't really know what's happening behind the scene. And sometimes you really want to like change some things, but you can't really do it because it's all within the LangChain library. So yeah, they don't really have like control over it. And they have also mentioned about scalability issues and some difficulties handling large volume of data. And I think this really still comes down to this high level of abstraction. Because again, like if there are some parts that they want to change in their application, it's not very easy for them to do that. I just found this funny meme. It says prompt template is just F strings. Not wrong. I feel like it's kind of true. You don't really need it, to be very honest. But maybe like when the applications is very large and there is large use case for it, it can be useful. Yeah, so that's the drawbacks. And there are possible alternatives, like the OpenAI library or SDK, for instance. It's not really like, I guess, a direct comparison, but in the open forum, a lot of people are saying that it's better at the end of the day to just call the OpenAI API directly or even use the library directly. And as you can see here, I feel like this is a very famous picture from DeepSeek API documentations that even in their example, they also use the OpenAI SDK in Python. Same with Meta Llama model. They're also using the OpenAI SDK. And over time, I think OpenAI has become the standard. The library, which is amazing. But yeah, this is one thing that people also mention is the fact that using OpenAI API directly, for instance, or using this library is better in a sense that performance-wise is faster. So that's one thing to consider. And there are other alternatives I found like Haystack, Llama Index. To be very honest, I've never really explored them. But yeah, these are the other toolings that people can use aside from LangChain. Yeah, thank you for listening.
In terms of time, you should be around later.
Yeah, I can ask later. Yeah.
So maybe after all three talks, we have questions. Please go talk to Hannah. If you have questions for her, right? And next up we have Daniel. There's some seats in front. If you would like to have a seat, folks are standing. I think if you come around there, yeah. Okay. Hello everyone. Is this volume okay for you? Okay. Yeah. Hello everyone, and I'm very happy to have you tonight with us. And my name is Song Yu. You can also call me Daniel if it's easier for you. And I'm from China. And currently, I'm working as a associate software engineer at Rakuten Asia. And before we start, I want to express my gratitude to Rakuten and also JuniorDevSG for this amazing opportunity to allow me to share some knowledge and insights on AI applications with you. And today my topic is about orchestrating large language model agents with supervision with the LangGraph framework. Yeah, and hopefully Hannah's presentation has given you some idea about what LangChain is about and how can we build LLM applications with it. And yeah, so this will be the agenda for today. Firstly, I will be giving you a quick demo on what kind of applications we can build with LangGraph. Then I'll talk about the motivation of using LangGraph. Then we'll be going through this agent supervision architecture and also what is LangGraph all about and how do we actually use LangGraph to implement something. And finally, we'll be talking about some future explorations as well as some questions you may have. So before we dive into the boring part, let's see a quick demo on what kind of applications we can build with LangGraph. So here you can see my screen, right? So this is a very simple chatbot. And so the first thing I want to ask about the chatbot is, I believe that all of you have used this kind of chatbot like ChatGPT or a DeepSeek or something else. You may have encountered the issue where the AI can give you falsifiable or wrong information because of the hallucination, because we know that the AI models are trained on history data. And if you ask something that is up to date, it might not have the ability to get that information correctly and respond to you. But nowadays, we are able to actually equip the AI models with tools like web search so that it can actually retrieve the data on the fly and it can return the correct information to you. So actually, does anyone watch Formula One? Okay. Actually, last week, there's a race in Australia. So let's ask the chatbot who won the race. So yeah, who won the F1 2025 Australia Grand Prix? So it's a very up-to-date information. So if we check on Google, it's Lando Norris, the winner, and then followed by Max Verstappen and then George Russell. But can our AI chatbot get this information correct? Yes, it can. It says Lando Norris won the 2025 Australian Grand Prix. Okay, good. So then I actually want to ask for some very specific definitions or informations that can be previously we can only find on websites like Wikipedia. So for example, what's the definition of AGI? Yeah, so this is also not a very recent concept, but still it's better that actually we reference from trustworthy websites like Wikipedia to find those information instead of asking AI, which can give hallucination and wrong answers. And also, I'm not sure if you have tried. Actually, the reason that Hannah brings the topic about calculator is that if you ask very complex mathematical questions to the AI, they can actually give you a wrong answer if you have tried models like GPT 3.5, because the way that AI models generate the answers is that they convert everything into tokens, which are basically vectors, and they predict the next word, next tokens with probability. But mathematical questions are not so easy to get answered with just predictions in probability. So we really need the tools like calculator to really get the answers correct. So let me ask a question about maybe what is this question? So hopefully the AI can also get it correct. Okay, now it respond with probably the correct answer, better than the GPT 3.5. And lastly, I believe that most of us are developers and we do use AI for a lot of general questions about coding. So let's ask maybe how to create packages in Python. Yeah, so very quickly it can give me the answer. So far nothing special, right? But if I tell you actually all these answers are generated by 4 different LLMs, is that amazing? Okay, let me show you. So actually in my backend console, the first answer about the F1 result is generated by this agent called chat and search agent, which is an agent that has the access to the web search tool. The second one about the definition of AGI is generated by a agent called Wiki agent, which has access to the Wikipedia. And then the third answer about some mathematical questions is generated by this agent called Math agent, which has access to this calculator tool. And then the last one, we are asking about some programming or coding questions, is answered by this code agent. So you can see that with this single interface, we're able to actually get answers from all the different agents or different models. And this entire application is actually built very easily with LangGraph. So then I will be talking about how can we actually build this, and hopefully you can build it, do it yourselves after this presentation. So yeah, let's go back to the presentation. So let's first talk about why we want to use LangGraph for this kind of user experience or this kind of app we want to build. So firstly is that we want to actually augment the information retrieval experience with the power of AI. So actually, since the introduction of ChatGPT, many people don't actually use, including myself, Stack Overflow that much, because now the AIs can easily give us answers on general knowledge for very basic questions and for some facts that happens like a few years ago. But if we ask something recent, it might give us the wrong answers. So that's why we need to introduce tools like web search. And so we actually want to provide a very universal user interface where we can allow the users to access to diverse information types and sources within a single interface. And also, we understand that different LLMs has actually different unique strengths. Like, for example, the cloud model from Anthropic is more capable in coding, and DeepSeek is a very the R1 model is very good in reasoning, and ChatGPT, their GPT like 4.0 model is good for coding tools. Yeah, so we understand that these different LLMs actually have their unique strengths. So we actually want to combine them and ensure that it can respond with the correct model, with the correct answer that is contextually relevant to the user's answers. And finally, we want to actually easily onboard new large language models, because every 2 or 3 months, there will be another new model out on the market, right? So how can we build a framework that can easily adopt to use the new models? So that's why we want to choose LangGraph for this purpose. Yeah, so, and the framework I'm talking about today is called LangGraph. It's a orchestration framework. So if we use analogy, LangChain is like Docker, and LangGraph is like Kubernetes. So you can build multiple chains and orchestrate them with LangGraph, which is really powerful. Yeah, so what is LangGraph about? It's an open source library for building a stateful and multi-actor application with large language models. And it is developed by the same company who developed LangChain. It is useful to create agent and multi-agent workflows by modeling the workflows as graphs, basically nodes and edges. We connect them so we can easily describe the workflow that we want. And it can be actually used independently of LangChain. So if you are currently using any other large language frameworks, this is also usable for you to try out. And this LangGraph is currently implemented in TypeScript, JavaScript, and also Python. So whether you want to build some web applications like what I did with the chatbot, or you want to build some backend to serve some APIs, you can easily use these supported languages. And the core benefits of LangGraph framework is that it supports cycles. So as what Hannah just presented, I believe that most use case of LangChain is linear. So it's basically a sequential order. You want to execute stuff step by step. But with LangGraph, we are able to create actually cycles to have like continuous operations. And it has a very good controllability where you can define all the states and nodes and edges in this graph. So it offers this fine-grained control. You can define everything in code so that it is more predictable. And finally, its persistence. It has the built-in persistence for us to have the memory features like what Hannah just showed, so that the LLM is better aware of the past history of our conversation, so it can generate better answers for you. Yeah, and then it's about this agent supervision architecture. Yeah, so what is this architecture about? Actually, it's quite similar to what Hannah just shared as the router chain. So basically, to understand it better, we use an analogy. So imagine you are running a consultancy business and you hire many experts, and each are specialized in some different knowledge domains. Like some are, for example, coding experts. Some are sales experts. So you are the supervisor, and your duty is to basically understand your client's needs and assign that particular request from your client to the correct expert so that the expert can handle the task for the client. And if we go to LangGraph with this architecture, it's actually very, very similar. So basically, we create nodes. One node is called supervisor, where it directly interacts with the user and understand the user's request. And its duty is basically to route the correct user's request to the agent nodes that are basically the experts specialized in some knowledge domains. Yeah, so if we go back to the picture, isn't this very similar? Yeah, so with this knowledge in mind, how do we actually implement this whole, for example, this chatbot that I built with LangGraph? So first of all, we want to select some models, right? So it's large language model application. We want to use models. Okay, yeah. So this architecture requires the LLMs to have the tool calling functionality, because router is essentially a tool. So the supervisor will need to access the router to correctly assign the task to the correct agent. And for that purpose, we want to use the GPT-4o Mini for the supervisor, because GPT-4o Mini is actually reasonably good in reasoning to understand your user's request and understand the system prompt that you provide to it. It is also very fast because we don't want to spend too much time on deciding which agent to use. And also, it's very cost efficient. The price for the tokens is much lower than other more capable or complex models. But for the worker agents, because we want to get the users the most correct or the most useful information, so we may want to consider to use some better models like GPT-4o. But in this example, I'm just using the models from OpenAI. This architecture or this flow allows you to use any models you want, like whether it can be the DeepSeek model that you deployed locally on your machine, or it can be Cloud from Anthropic, it can be Gemini from Google, anything. We are just using OpenAI's models for demo purpose. Yeah. Okay. And for the tech stack for the chatbot I used, it's mostly because it's basically a web application. So it's very close to the front-end tech stack. Like we use Node.js and TypeScript and Next.js to handle the application itself. And we use Vercel's AI SDK to build the bridge between the front-end UI and also the LLMs. And then we use the LangGraph to create the whole routing mechanism. And of course, we are using OpenAI's model, so we are using the OpenAI library to invoke the LLMs. Yeah, so with LangGraph, we can easily describe the supervisor and agents in code with the following steps. Actually, only 4 steps, pretty easy. Firstly, we want to define the state and create an empty graph. And then we define all the nodes, like these circles, rectangles in the graph. And then we connect them with with edges to define their relationship and the transition between different nodes. And also, we need to add an entry point where the user interact with. And also, finally, with this graph and nodes connected, we just use the compile method. And finally, it is able to be invoked to give you the final answers. So let's go through the steps one by one. So the first step is to define the state and create an empty graph. So to build an to build a long graph application, the first thing you need to do is to define a state. Here we call it agent state. So it is basically just a simple object that is passed between nodes to exchange the information and understand which step you are currently in this application. It includes the information on the basic structure of the graph so that each node is aware where we are. And it also allows you to define a reducer method, which is basically a function that specifies how each node should update the state, update this object to pass the latest information to the next one. And here we define two important fields. One is called messages. It's basically the text, the chat conversation we have. And then there's another property called next. It's basically deciding, okay, who should respond next? Should it go back to the supervisor? Should it go to the math agent, or should it go to the web search agent? So next is basically holding this information to let the graph understand which agent or which step should we take next. Yeah, and then we want to initialize an empty graph. So graph nodes, they communicate by writing and reading the shared state object that we just discussed earlier, and so that we need to pass the agent state to the graph. And then we want to define the graph nodes. And firstly, we want to define the supervisor. So the supervisor is responsible for routing your user's requests, right? So we just actually, it's pretty simple as well. Firstly, we want to define what are the members available. So basically, which agent nodes that I can route to. For example, it can be a chat agent, which is for general chat purpose. It can be a code agent, which is capable to answer complex coding questions. And it can also be math agent, which is a math expert to give you the best mathematical question answers. And we will put some system prompt to the supervisor. So basically, I'm saying that, okay, you are a supervisor. You should understand the user's request. You should assign the task to the next most reasonable agent that is capable to answer the user's question, which is quite straightforward. It's in plain text. And finally, we need to give this supervisor a routing tool. So this is actually the tool that the supervisor used to decide the next node that it should transition to. Yeah, and we will also need to build a simple supervisor chain where it can function as what Hannah just shared, have multiple stages of input and output that are chained together. Firstly, it has to format the prompt because the supervisor needs the system prompt to understand the routing task. Then we want to give it the routing tool so that with the input and user's prompt, it can decide the next route to use. And then we want to parse the output from the LLM and then format it into JSON so that we get the answer of the result of the routing. So it will basically show you something like next chat search agent, next code agent. So this will be the output. And with this output, we are able to understand which agent node it should transition next. Yeah. And with the supervisor ready, we then will go ahead to define the graph nodes, basically the agents. And each agent can have their own tools. For example, the web search agent has the access to a web API, and the wiki agent has the access to the wiki tool to download information from Wikipedia. And also, again, the math agent can use the calculator to calculate the answers based on your request. And here we are using a built-in function called create React agent. This React is not the front-end framework React, but reason and acting. So it means that it can understand your request based on the prompt input and perform actions based on its understanding. So here we provide the tools and also another system message to tell this expert or this agent what you should do. So for example, I'm telling that this should be a math expert. So it understand, okay, I am handling mathematical questions. I should probably use the calculator to answer my user's question. Yeah. And with that definition, we can create a node called agent node where you know that actually in LangGraph, the nodes are represented as functions, which are pretty straightforward and easy to understand. And this function will just invoke the LLM, basically the GPT-4o, with the current state as the input. Basically, the state holds the past history of the conversation. And then it processes the React agent's output and format it into a new state that can then be passed to the next stage. It can be like returning directly to the user, or it can be in other stages of the graph. Yeah. And finally, we defined all the agents and the nodes and also the supervisor node. The next step is to basically connect all of them. Firstly, I'm adding the supervisor chain as the supervisor node to the graph. Then I can add all the agents available, the agent node, and also add an edge from the agent to end. And so end means basically we want to stop the conversation so that once the agent gets the answer, we want to directly return it to the user. And finally, we want to add a conditional edge. Basically, this is the part that routing happens. So we give the supervisor a link to all the next possible agents so that it understands, okay, I can jump to that agent state conditionally based on whatever the routing decision I have made as a supervisor. And finally, we add the entry point. It's basically the starting point. The user's response will be directly forwarded to the supervisor to start all this routing mechanism and also the question answering. Yeah, and finally, with the graph filled with the edges and nodes, we can finally compile it and then invoke it with the methods that are built in, like the stream events, so that we can get the answers by streaming. And it works exactly in the same way that ChatGPT works, where you can see your answers get generated in real time. Yeah, so that's quite straightforward, right? So you only need 4 steps to build this chatbot with this routing agent supervision architecture. And let's now talk about some future explorations with this LangGraph and also our application built. So firstly, we want to actually explore more integration with open source large language models instead of just the OpenAI GPT models, because I believe that you all know that actually nowadays many open source models have better capability in reasoning, in mathematical, in coding questions than the OpenAI's model. But OpenAI did package all of their models with very easy to use and intuitive APIs. But why not explore the open source LLMs? They are free. We can just do self-deployment on our own servers. We have better control. We can fine-tune on our own data. So we can build this entire solution for our own products. So let's say you're building some coding assistant. You can build multiple agents that, for example, one can connect to Stack Overflow to give you the whole human answers. One can connect to Google Search. One can connect to whatever database you have so that it can answer you all the best questions. And open source large language models are already capable as the GPT-4o models that we use today. And we will also like to explore some other architecture patterns available in LangGraph. Today, it's just agent supervision, basically routing your request to the correct LLMs, so that you can add infinite number of agents to your chatbot, and it can answer the correct questions and answers to your user. But there are also some other patterns like collaboration. So basically, the agents themselves can talk to each other to do multi-stage reasoning and finally compile all the output to the user. So if you are trying to build some research tools that requires several steps of reasoning and tool calling to search the latest information on the internet, this kind of pattern might be suitable for your use case. And finally, we may want to create some generative UI to display the search results in UI components instead of just text, which might be easier if you want to build a product for maybe for kids, for elderly, the UI will be much easier to read compared to just text. And finally is that we actually want to consider optimizing the cost for production use. If we want to actually serve this in public traffic, you know that actually LLMs are not cheap, not at all. So we will really need to consider either do self-hosting of open source models, or we try to think of some mechanism that can save us some cost while serving our users' requests the best way. Yeah, so that's basically my presentation today. Let's quickly conclude. Firstly, we went through a quick demo of the chatbot that can be built with LangGraph. Then we discussed about the agent supervision architecture. And finally, what is LangGraph all about? Why do we use this open source framework? And finally, the implementation details of creating this chatbot with the supervision graph and also the future explorations. So also maybe in the interest of time, we can answer your questions later. And yeah, feel free to connect with me on LinkedIn or GitHub. Yeah, that's my presentation. Thank you so much.
Awesome. And last speaker for the evening is Thomas Kokani. Yeah, cool. It's all right. I can be loud or both for recording. Okay. Thank you. So imagine that you started your first day as a software developer. I guess many of you have been there. I do remember my first day. It looked like this. I went to the first meeting with the first dev that I met, my manager, and we went through all of these technologies that I had no clue about. And I do remember the feeling, how is it that they are telling these technologies, you're trying to write it down, and you don't even know how to spell it, and so on. And it's like, oh God, what's gonna happen with me? And that's usual. If you are working for a company, it's very likely that they have a huge complex system because that's what makes money. And it's a big issue, or it's a big problem if you are a junior developer. How are you gonna be the person that really helps with this heavy lifting with all these technologies, and not just somebody that's just there and learns about stuff and so on. So how can we accelerate this process? And how many juniors, or who considers themselves a junior? Nice. Then the other, how many seniors? Okay. So the talk is for both of you, actually. So I'm going to talk about what can you do if you're a senior, and how can you be a bit more conscious about it? How can you help juniors? And also, if you're a junior, what's okay to ask from a senior, how to find your place, what are good strategies to learn, and so on. And you could ask the question, or maybe you started to wonder, who the heck is this guy talking about this and why I'm talking about this? So I'm Tamás Kökény. It's a Hungarian name. Don't worry about it. My nickname is Egg in Hungarian. It's called Tojás. So if you don't remember, just call me Egg. It's totally fine. I guess it's easier to remember that. You could also ask, why is a Hungarian guy in Singapore? I'm not at all Singaporean. I'm just visiting for 2 months because I love the city. It's an amazing place, amazing food, amazing people, amazing weather. And I also reached out, can I speak in a meetup? Because why not? And I'm the CTO of Bobcats Coding. Bobcats Coding is a small software agency or software studio. We help people to build products, not just the development part, but design, product management, and everything. But that's not the interesting part. I'm the same person. Yeah, I got fat. Never mind. But I was the head of education of a programming bootcamp in Hungary, and actually in Slovakia and Czech Republic for 8 years. And in that institution, we had more than 3,000 students becoming developers. And I've seen this pattern, these people going to the jobs and talking with these people, how is it? And also talking with the companies, because we had a business model where we were placing these students and we were talking with the senior engineers as well, if they like the people and so on. So I got a bit of an information or experience about how is it to be a junior and how is it to be the senior that basically onboards this junior person. Maybe you have already heard about this idea about software, that software development is closer to craftsmanship than to engineering. It started to become kind of a de facto idea in the last couple of years, not just now, but more like 20 years ago, that there is this act. It's not just about science and engineering, but it's closer to some kind of a craftsmanship, how we create software and so on. And there are quite a few ideas around this, that we do agile development and lean development and so on, and extreme programming and so on. And these are really, really nice ideas. And it basically shifts our mindset about how we develop software. But it's not just this kind of thing happened in education as well. And when we are developing our software development, the first idea is, okay, what are the hard skills and how are we going to develop software and so on. But the biggest skill that you have to acquire if you are a software developer is constant learning, because from now on and from the beginning of your career and still now, I'm in the industry from 2009, and still I have to learn LangChain because it came out nowadays. And I cannot stop, even though I have more than 10 years of experience. So this is the most important skill, but somehow it's overlooked. Somehow we don't start to think about it. Okay, I'm gonna be the best learner just about technology and so on. And actually the same kind of idea how it changed about software development, and there are quite a few books about craftsmanship and so on, and how you build software, like from clean code and so on. There are books about how to learn. And we can learn a good amount of them. So this is from '92. That's when they started to think about, okay, this is software craftsmanship and the programmer and so on. But in education, the progressive education movement, it's from the ancient Greeks. And there are quite a few ideas, but also there are books and ideas from John Dewey from the end of 1880s, and also beginning of 70s, the experiential learning model. And we can learn a good amount of things from here. And I'm not going to go into exact details about the science, but I basically cheated and I took a good amount of ideas from these books and so on. But okay, there are these ideas, but usually the implementation is the tricky part. If you read clean code, you read it, oh, it's so nice, but oh, how am I gonna really read clean code? That's the hard part. And in this talk, I really want to give you a couple of ideas that, okay, what's the day-to-day that you can implement something and you can really do something in the next day to learn easier or be more useful or something like that. So the first idea is to set up the learning environment. And let's talk about these two. Maybe you haven't heard about learning and performance zone. The idea here that there's two ways that you can approach a problem. One is the performance zone. Performance zone is that you approach a problem, you think about what's the most performant way that I'm going to achieve this. And usually that's 95% of the time, this is how you are basically approaching problems. When you are washing the dishes, what's the least amount of time and most performant way that I'm able to do the dishes? The other way of thinking is the learning zone, when you are giving yourself space and time, and it's not, the most important part is not performance, but rather how am I going to learn this thing and how I'm going to be able to retrieve this whole idea later in different contexts and so on. And in Learning Zone, you have to create an environment where it's totally okay to fail. It's totally okay to try things and fail again and so on. So it should be some kind of a process where you're able to repeat stuff and get back to something if it's not good enough yet. And also, what's really important in every cycle, you have to reflect. And actually, that's the hardest. So when you are starting to do something, you start a new technology in your first job and you start to write something, right away you get to performance zone because, oh, I have to finish this. I have to show to my manager that I'm okay, I'm worthy, and so on and so on. But actually, it's way better if you start to be conscious about it. I haven't learned this technology before. It's hard. It's all right to fail with it. Just start to write something, put it out there, test it, figure out why it doesn't work, and so on, and also be mindful about stuff that you don't yet understand. I guess you already started to think that next I'm going to be talking about Beyoncé, but actually Beyoncé also talks about this and actually approach this when she's on tour. Performance zone when they are doing the concert. Done that, amazing, but after that, basically the whole team, and a concert like this usually employs around 300-400 people. The whole crew goes to a movie theater and they rewatch the whole concert from yesterday. And they give space for go through on each of the small problems. They take notes. They basically reflect on the whole idea, what they did yesterday. And it's really important to have this mindset because it's really easy just do something. I haven't really understood what exactly happened, but it kind of worked. I was able to finish a Jira ticket or something like that, so I'm done. That's not something that's going to help you recreate the same kind of idea later or use that idea in different contexts and so on. Another hard issue is to find a team. When you join a new company, usually what junior people are thinking about that, okay, I just pick the team. Sometimes you are able to pick the team and sometimes the team is choose for you. But somehow that's the idea that, okay, if you get to a team, you're gonna die there and that's it, that's your destiny. But actually it's really important that it's just a team. And especially with bigger companies, it's totally all right to change teams. And it's really important to figure out from the company's point of view if there is buy-in for the person. And also to basically check out if there is really team fit there. And if you're a junior person, it's totally fine to tell to your hiring manager or something like that, that I've spent this amount of weeks here or month here, and there's nobody mentoring me, nobody's helping, the vibe is not really good or something like that. That happens, and it's not something that you cannot talk about. That's totally fine, and you can change teams. And it's way more important to find a team where you're gonna be happy than to find a company. In many cases, people are asking me that, oh, I'm a junior, is it okay to, or is it a good idea to join this and this company? It's really gonna depend on that one guide or person that's gonna help you or not on the team. And if you're gonna be happy for the next couple of years. So I already started to talk about this to find a mentor. If you're a senior or you have some kind of a agency here, it's really important to be conscious about this and pick explicitly a mentor for a junior developer. And also not just dedicate a person, but also dedicate time. But what's also important if you are a senior developer, if you are a senior developer for somebody, it's very likely that they're gonna idolize you in the long run. Not just on the long run, on the really short term. And it happens the other way around. When you're a junior person and you see the other, I don't know, they are in the industry for 20 years now, and I don't know, they are using VI and quite a few different tools that you have never seen, and they are writing a function in a couple of minutes that could take you a week to finish and so on. Remember, they are just people. Unfortunately, this whole job is about our way of thinking and about our brains, but it's not about your abilities. It's really about your experiences. And I really like this comic about it. I give you time to read it. So the only difference between a senior person and you, the amount of error messages that they have seen. That's it. And so if you weren't provided a mentor, that's also totally fine to ask somebody to be your mentor, or also ask HR or the hiring manager or somebody or your manager that I would like to get better. I would like to have dedicated time and dedicated person for mentoring. But it's also really important, and especially with these mentors, and basically to break down this difference, it's to meet with others in not just work context, but in different environments as well. Because when you meet these idols that are coding for 20 years and they're totally different, and you're thinking that you're not going to be there, I promise you're going to be, just you have to see a bunch of error messages. But you're going to see that they have the same problems as you. They have a cat that misbehaved last night and so on. So they are just people, and they don't have a magical talent or something like that. So I think I don't have time for wrap up, so I would just summarize what we have talked about. So let's go to the next topic. What to learn? It's also important, okay, you have the space. You learn, you were able to give your space and also find somebody that mentors you and so on. But it's also important to be conscious about the things that you have learned or you are learning. One really important topic is familiarity bias. If you see something that's familiar, that means that you're already gonna like that. But it's also happening with learning. You are not just thinking that you are liking it, but you also think that you know it. In many of the cases, if you learn something and you see a concept again and again, you think, oh, I'm familiar with this. I've seen this before. I know this. But I'm pretty sure if you're gonna use that concept in an environment where it's not shown to you, but you have to come up with that concept, it's gonna be way harder. For example, I was teaching solid principles the first time. If you don't know what solid principles are, you should read the Clean Code book. It's totally fine you don't know yet, but on the long run, please read it. it's an important thing. But basically, it's an abbreviation, and every letter is some kind of a principle. And when I was teaching it, I figured that I thought I know the solid principles. But when I was teaching it, I had to go through on each of them, and I had to explain all of them. And I figured that I always started to read the solid principles, and I got bored, and I only get until L. And when I started to read it, S was really familiar. I know the solid principles. Oh, okay. But I never went to I and D really deeply because I got fed up with it. So I had this idea that I know it, but when I had to teach the I and the D, I figured, oh, this is the problem. And you have to conscious with these ideas that just because you read the beginning of the documentation many times, it doesn't mean that you know the documentation. So you shouldn't cheat yourself. You should be conscious about the things that you don't know. It's also important to learn about the domain. It's not just about the tech skills, but also how that business works, how they make money, what are all the abbreviations that they are talking about, and so on. These are also really important, and you are not just paid for that you are able to write code. You're paid for that you are able to figure out big problems and basically help business problems by coding. Also, what I really advise if you join a company to read the architecture, and by reading I really mean open the whole code base and start to read it. For example, figure out where is the main function of that code base. How it's going to start there. What are the next thingies that's going to be called in the main function and so on. Usually code bases are not really huge from the point of view that you are able to put it on a Kindle. If your company doesn't allow it, you will be able to do it differently. But for example, with my first job, I put the whole code base on the Kindle, and I was reading it on commuting. And it helped a lot to figure out what's there, what are the bits and nits, what's the coding style there, and I learned a lot just reading the code that I have to contribute to. Also, if quite a new tools are introduced, even like big tools like, I don't know, AWS or something like that, or build tools like Gradle or anything like that, I advise you to have some kind of a pet project and use the same tools. Even if it's an enterprise tool, it's really important to use it for smaller projects, because in these smaller projects, you will be able to see those error messages that you don't want to see in the real project. Or if you see those error messages, you've already seen them in a small project and you fix them. And you're not going to be totally scared that, oh, I deleted the whole database or something like that, because you already used those tools in a different environment where it was okay to fail with. And it's really not just the hard skills. It's really about coming down to communication skills, facilitation skills, giving feedback, receiving feedback, and so on. And a usual other thing that I see with juniors, that they don't participate in the demonstrations. That, oh, this more senior person will facilitate the meeting, the more senior person will show what we have done and so on. But I really advise you to step up even in your first week or something like that and demo the stuff that you have done and so on, even in cases where you're presenting for other teams or clients or something like that, because you're going to learn a lot from that. And also it's a good pressure to basically prepare yourself for these. The last part is to how to learn. One is learning by doing. I already mentioned that it's way better to have a project like a hobby project, because it's going to require you to go through a good amount of things that's going to help you in the long run to learn. And actually, if you have this experience with projects, I'm not going to go into the really depth of the cognitive science behind learning, but if you have some kind of an idea already in your brain and you connect another idea with it, it's going to stick better. And if you have a project and you're going to use a concept in it, that concept going to stick way better than just reading about it and that's it. I'm also don't have time to that. And it's also not a sprint. So don't think that, okay, in this project, we're going to use React. I have never used React, so this week I'm going to learn React, and that's it. I'm using React basically since it came out, and I still don't think that I'm a React expert. I do think that I know some things about React, but it's really something that you have to learn continuously, and even the basic stuff. So another thing that I totally advise, if you're a senior and you're telling that big introductory meeting, all the technologies or the architecture, what's going to be your role and so on, if you are that senior, I advise you to retell that meeting a month later and 3 months later and so on. And if you're the junior one, ask for that again and again and again, because you're going to have way more context about it. Because on the first meeting, you're happy if you're able to write down the 80% of the technologies correctly or spelled correctly. But if you're working there already and you already tried most of the technologies, if that story is retold, you're going to understand way more depth from it. So I also advise to go through tutorials or even textbooks that you have learned from 2 years ago, a year ago, 3 years ago, or something like that, and read it 1 year later, because it's going to give you way more things. For example, I read Pragmatic Programmer quite a few times, and I learned a lot each time, and usually I've spent 5 years between these. Okay, another thing is one-on-ones. If you are not scheduled with one-on-ones, ask for them. I think one of the best things that you can have in a company is somebody that does a one-on-one with you. From their point of view, it's important that the company or the mentor is able to clear the expectations. If they're not clearing the expectations, then it's your job to do it. So basically, ask for, am I good enough in this case? What's the exact expectation for my progress in the next couple of months? What do you expect me from end of this year? Where should I be, and so on? Because there's gonna be a good amount of myth, especially when you're a junior. What do they really expect from you, and what are the important things about your skills and not important skills, and so on. Also, if you're a mentor, it's important to give a vision. If you're a mentee, I think it's hard to ask for a vision, so never mind. Also, if your mentor, it's important to coach your mentee. If you don't really get coaching, I really advise you to get help outside of the company, because in many of the cases, if you're stuck with some kind of a problem, in many of the cases, it's not necessarily a technical problem, more like how you're facing problems, how you're able to achieve stuff, and so on. Regarding feedback, it's really important to receive feedback. So if they don't give feedback, ask for it explicitly. If you're on the other end, you're giving feedback, the most important part is to do it regularly and do it on behavior. And also have this positive mindset about it. There have been studies that the good ratio on positive and negative feedback is 6:1. So if you are below that, it's most likely the channel is gonna be getting worse. If you are in not that culture, that's totally fine in the company. But you can also ask about stuff, what went good, even if you are the junior person, because you can also learn from the good stuff, not just from the negative things. Because if they tell something that went good, that means that it's easy to repeat the same thing. And you're gonna have way better results with repeating stuff that they already like. To receive feedback, actually, that's also a skill. What's the rule for receiving feedback? Treat it as the ugly sweater that you got on Christmas. Say thank you, smile, and go away. And that's it. Don't say back that it's ugly. Don't say back that I don't need it. That's not for me, anything like that. It's totally fine to think that, but outside. And why is it important? Because if you're gonna resist the feedback, you're not gonna get feedback later, because they're not gonna like giving you feedback. And it's one of the most important things that you can get is feedback. So we also don't have time for this. So we went through quite a few ideas. So the last part is just some basic tools that you can use. If you are somebody that's helping another, so you are the more senior person and mentoring somebody else, a really good tool is not to give the exact answer. It's basically this idea that don't give the fish, but rather the fishing rod. It's way better if you are able to coach them to get to the answer, to figure out the whole idea, the context about it together, and then they're gonna be able to figure the answer. By explaining why, I really mean it's just giving the context about the problem. And in many of the cases, if they have enough context, you're gonna be able to figure out the solution. I also advise this. When you are getting a question or giving a question to a more senior person and they just give the answer, also ask for the context. Why is that the answer? How could they come up with that answer, in which context, and so on. Another good technique, if you are the helper, is to never take the keyboard of the more junior person. It's intimidating, and yeah, I don't think I need to go into the details. From the other point of view, if you are stuck with some kind of a problem in your code, the best thing is to read the code out loud. And I'm not talking about the rubber ducking problem that you are talking with the rubber duck about the problem, but really read the code line by line and think about the code in a way that if you would be the interpreter or you would be the compiler. And even just use a paper and pen and use it as your memory and so on. And if you start to go through the code that way, it's most likely that you will be figure out what's going bad there. And also, your real job as a junior is to ask more questions that you're comfortable asking. And yeah, you have to ask not just a bit more, but double or triple times that you're comfortable with. It's way worse to have a person that's not asking questions and trying to figure out something, and because of that, they are always stuck, than to have the annoying person always asking questions. Actually, it's way better to be that annoying person than the one that stuck with problems. Another nice tool is pair coding. Yeah, I love this image. If you don't know this exactly, search for April Fool's Atlassian and pair coding, and they have a whole video about it's genius. Never mind. So with pair coding, if you don't have pair coding sessions, ask for them because these are really useful. But also you can be a bit more conscious about pair coding. And you can choose your style if in the pair coding sessions is who's going to be the active and who's going to be the passive one. And it's really nice if you're conscious about this. And actually, both can help a lot if the more senior person is the active one and you are able to watch that person, how they are writing code. But also the other way around, if you are the active one, you are writing code, the advices they are giving and so on. And if you are the active one, regardless if you're more senior or junior, it's really important to think out loud all the time. So basically, if you are doing something, just tell what are you doing exactly and so on, because it helps with the conversation way better. If you're the senior person, even go into details how you are exactly doing your job. Even tell about the keyboard shortcuts that you are using, the plugins that you are using, and so on in your environment, because these are also really important informations and messages for junior people. So you could ask why you should do this if you're more a senior person. And one is you're going to learn your tools way better, because if you have to explain your tools, you're going to learn them way better. For example, with the unique keyword in the shell, I thought that I was using it right for 10 years. Then I started to teach shell scripting, and I figured, oh, I didn't know that you have to sort stuff before you are uniquing something. So I figured that I gave quite bad answers to investors about active users and so on for 10 years because I wasn't teaching unique, and I haven't went to details. Also, if you're that senior person, it's one of the biggest impact that you can have to mentor somebody else. They're not gonna remember about the exact, I don't know, mapping or for cycle or anything like that they were writing. They're gonna remember you because you were the one that helped them and so on. And I guess we don't have time for questions, but thank you for the opportunity.
Okay, right. Before the last, so this is the last thing for tonight, hopefully. Okay, thank you all the speakers, Hannah and Thomas and Daniel for your sharing. Round of applause lah, no. Anyway, yeah, so before we close for the night, I just want to share a little bit about something we're launching today. JuniorDevSG has been running a mentoring program for the last 6 years, since 2019. So we do a mentoring program at least once a year, and this provide career coaching and guidance, and to help the mentees in making right decision. So say that's sort of the goals of the mentoring program, to provide good mentoring for people, also help folks with professional growth and also learn some best practices of the industry, working with peers and also with seniors and people who have been in the industry for a while. In the audience today, we do have a number of folks who have been our mentors and also mentees. So maybe for the mentors, wave your hands. Yeah, anyway, so. Yeah, and the mentees, if you don't feel too embarrassed about raising your hands, you can do that too. Okay, cool. Anyway, yeah, so the mentoring program this time around, there's some changes. There's going to be 5 sessions, once every 2 weeks. So it's on Tuesday night, and it'll be in-person session. So there'll be presentations by the mentors on specific topics, and then there'll be breakout activities. And then, of course, the mentoring groups are also encouraged to arrange for additional gatherings in between. It's a career track, so it's a career mentoring track whereby in each group there'll be at least two mentors and up to 5 mentees. So we want to have like good balance and also not just hear from one person's perspective. So we have multiple. That's why we have 2 mentors per group. These are the dates. The mentors will start with a mentoring or mentors orientation, just to get their sense of let them know that, hey, look, there's this thing happening. What's our expectation as organizers of the mentoring program for our mentors, and also for the mentors to also first time meet their mentoring partners. And the mentoring kickoff will happen on the 10th of June. So there'll be a kickoff session where the mentees will be introduced to all the mentors, and there'll be like a networking session and some activities together. And then after that, there'll be 5 sessions of the career track. And after that, there'll be a graduation. On the last day, there'll be graduation. So the closing date for application is the 1st May. So if you are interested or you know any friends, take a picture, share this with your friends. We're looking forward to have you at our mentoring program. There's also a capacity limit. As I said, there's a ratio of 2 mentors to up to 5 mentees. So try to make sure that we don't take in too many mentees. Of course, we welcome as many mentors as we can. Of course, tell your friends, tell your colleagues, tell your seniors in your team who you think will be great mentors to join us in this program. We started this with pilot run back in 2019, just before the pandemic. These are some photos of some of the mentors and mentees in our group. We also have some social things, so it's not just all serious things. Yeah, so this is for our 4th batch in 2023. We just finished our 5th batch last year. So this is 2023. Also quite a lot of people. You can see the mentors that do their sharing sessions where they will basically be talking about stuff. And yeah, so some of the mentors and mentees who was with us. Yeah. So again, sign up form is here. Scan this link. You see the form, a Google form. There's 2 forms, one for the mentors, one for the mentees. So please do figure out which is the form you'd like to fill up. And if you'd like to find out more about the mentoring program for the mentors and mentees, we have Zach back there, Max down here as mentors, and then we have some of the mentees are in the midst as well. So yeah, do check in with them if you think this is something that you would like to take part of. On top of that, Thomas talked about pair programming. We also have this little session that we run once a month. It's developers gym. So it's like, you know how people go to gym to work out, we go to gym to code, right? Never mind. So yeah, so basically it's to practice hopefully in a fun and unintimidating way. So basically, you're not working on production code that will break in a bad way. We're working on a small hobby project or on a coding puzzle. It's not leak code hard kind of thing. Okay, this is not leak code hard. It's just leak code very simple. Right. So some coding puzzles we work on together, and we'll basically try and solve it together. And of course, through this, I will also hope to share with us some coding practices like test-driven development and pair programming. Yeah. Okay. So take this QR code if you would like to join us. And hey, that's all I have for today. And one last, I promise this is the last QR code. Feedback. As Thomas said, feedback is an